Previous section, we have looked at sum and difference formula for cosine, sine and tangent. Now we will look at double angle and half angle formula. We have a double angle formula for cos 2a and sine 2a and also tangent 2a. For cos 2a, we have three types of equation. One is cos squared a minus sine squared a. Another one is 1 minus sine squared a. And the third equation is 2 cos squared a minus 1. So we can use either these three equations, depends on its needs. Now let's look at this example. Given that we have a sine a equal to 3 over 5, where the range of a is from pi over 2 to pi, we need to find sine 2a, cos 2a, and tangent 2a. Recall back the Pythagorean identity, where we have sine squared a plus cos squared a is equal to 1. Since we know the information given is sin a equal to 3 over 5, so we can substitute this information in this equation. And we get 3 over 5 squared plus cos squared a equal to 1. From this equation, and we solve it, and we get cos squared a is equal to 1 minus 9 over 25, or it is equal to 16 over 25. And here we just can find cos a is equal to square root of 16 over 25, or if we solve this, we will get cos a either plus or minus 4 over 5. To determine whether cos A is plus or minus 4 over 5, we look back at the restriction given here. The range of A should be in between pi over 2 to pi. Therefore, we can know that we have cos A is at quadrant 2. And in quadrant 2, cos A must be negative. Therefore, our cos A is equal to negative 4 over 5. Since we already get sine A, we already have the information of sine A is equal to 3 over 5, and we calculate and get cos A is equal to negative 4 over 5. So we can find the tangent A is equal to sine A over cos A, and we get tangent A equal to 3 over 4. And we know that the tangent A in quadrant 2 is also negative, so it's now our answer is correct because we have a negative 3 over 4. Since our question wants us to find sines 2a, cos 2a, and also tangents 2a, by having all this information, we can substitute in a formula of double angle for sine 2a and cos 2a. So sines 2a, we choose this because we have information for sine a and cos a. Substitute in the formula and we get negative 24 over 5. Okay, for cos 2a, so we use this formula since we have the information for cos and sine, we substitute in the equation and we get 7 over 25. As for tangent to A, you can use either this formula or this formula to get the answer for tangent to A, and whichever formula that you use, you must get the same answer for negative 24 over 7. Now let's look at this example too. So by using addition formula for sine, we need to write 3x in terms of sine x. So recall back the formula for sum for sine. We know that for sine 2x plus x is equivalent to sine 3x. So expand this using the formula of summation for sine. So we get sine 2x cos x plus sine x cos 2x. As you see that we have a double angle for sine 2x here and double angle for cos 2x here. So we substitute in the formula for sine 2x. We know that we have equal to 2 sine x cos x. So we substitute in the formula and we get 2 sine x cos x. But since we have cos here, cos times cos, we get cos squared x. And then plus sine x and cos 2x. So for cos 2x, we have 3. If you recall back the formula for double angle, so we have 3 equations for cos 2x. So we can choose the second formula because it is more suitable, which we want the equation to be in terms of sine. So we choose 1 minus 2 sine squared x. And then we we expand the equation, and if you see here we have cos squared x, so we can change the cos in terms of sines by using the formula of Pythagorean identity, which is sine squared x plus cos squared x equal to 1. Therefore, cos squared x is equal to 1 minus sine squared x. So we replace this equation and it will become 2 sine x multiplied with 1 minus sine squared x plus sine x minus 2 sine cubed x. So since all the equation in terms of sine, so we just can expand and simplify the equation and we get 3 sine x minus 4 sine x cubed, 3 sine x minus 4 sine cubed x as the answer for this problem. Let's look at other option, how to solve the previous problem. Let's say we choose a different formula for double angle for cos, and we choose cos 2x equal to 2 cos squared x minus 1. Okay, so as we expand the equation, so we find that 2 sine x cos squared x can be plus with 2 sine x cos squared x. So we get 4 sine x cos squared x. Okay, we have here 4 sine x cos squared x minus sine x. So again, by using Pythagorean identity, so we can change cos squared x and become 1 minus sine squared x. So the same thing, we expand and get this answer for the problem, which we have the same answer as previous method. Now let's look at this exercise. Pause your video and try to do it yourself. For this exercise, we want to find the double angle for sine, cos, and tangent. The information given is we have a cos A equal to 3 over 5 with a region of for 3 pi over 2 to 2 pi. So first we try to find other information. So we have cos. So let's say we want to find sine A and also tangent A. So we can use a Pythagorean identity which is sine squared A plus cos squared A equal to 1. So we substitute the information that we have, and then we have sine squared A plus 3 over 5 squared equal to 1. So we can find sine A equal to 1 minus 9 over 25. So we can get this equal to 16 over 25 for sine A, sine squared A. So for sine A, we can get square root of 16 over 25, which is equivalent to plus minus 4 over 5. Okay, to determine the answer for the exact value for sine A, first we must look at the restriction that been given, where this is at quadrant 4. So you must know that for quadrant 4, we recall back from previous lesson, all cos value are positive. Here for quadrant 1, all value for trigonometric are positive. Here is all for sine value, we have a positive, and here for third quadrant, we have a tangent value, which is positive. And we see that we are at quadrant 4, meaning that all cos are positive. So for sine, we will have a negative value. So we have sine A equal to negative 4 over 5. So since we already have cos A equal to 3 over 5, sine A equal to negative 4 over 5. So we can find tangent A, which is equal to sine A over cos A. So we substitute the value of sine A and cos A. So we will get negative 4 over 3. So by having this information, so we can find the double angle for sine 2A, which is equal to 2 sine A cos A. Substitute the value. And we get the answer is negative 24 over 25. Next, we can find the double angle for cos. So we choose cos squared A minus sine squared A. Substitute 3 over 5 squared minus negative 4 over 5 squared. So we get the value for double angle for cos is negative 7 over 25. Lastly, we can find the double angle for tangent, which is sine 2a over cos 2a. So substitute the value and we get the final answer for double angle for tangent is 24 over 7. So we solve the problem. Now look at exercise 2. Pause this video and try to do it yourself before looking at the answer. For this exercise, we want to find the double angle for sine, cos and tangent. So the information given that we have tangent A equal to negative 4 over 3 and the A is the range from the range for A is from pi over 2 to pi. Since we have the information for tangent A equal to negative 4 over 3, so we recall back Pythagorean identity that involves tangent, which is 1 plus tangent squared x. Oh, now we use A, so tangent squared A equal to secant squared A. So substitute the information. So we can get secant squared A equal to 25 over 9. Therefore, we can get, we know that secant squared or secant A is equal to 1 over cos A. Therefore, we can find this is also equal to cos squared A equal to 9 over 25. And cos A is equal to plus minus 3 over 5. So recall back our A value is between pi over 2 to pi, where this is at region 2, quadrant 2. And we know that quadrant 2 for cos is C A S T. So quadrant 2, the value for cos at quadrant 2 is negative. So for cos A, we get negative 3 over 5. Actually, we can use the quadrant 2 and draw the triangle at the quadrant 2. So we have this angle. So we have cos A equal to 3 over 5. So cos A 3 over 5. So meaning that here will be 3, here will be 5. And we know that tangent A is equal to negative 4 over 3. So tangent of 4 over 3. So meaning that here is 4, here is 3. Therefore, we can find sine A, which is 4 opposite over hypotenuse 5. So it is positive or negative. So since it's in quadrant 2, so quadrant 2, therefore sine is positive. So we get sine A equal to 4 over 5. Since we already get the value of sine A, cos A and tangent A, now we can find the double angle for sine, cos, and tangent. So sine 2a, 2 sine a, cos a. So substitute the value. So we get negative 24 over 25. Now cos 2a. So we use cos squared a minus sine squared a. Substitute the value. 5 squared minus 4 over 5 squared. So we get negative 7 over 25. And lastly, the double angle for tangent. So we get negative 24 over 25 divided with negative 7, sorry, negative for cos 2a, negative 7 over 25. So the final answer for double angle for tangent is 24 over 7. So we already answered all the question needed. Now look at the half angle identities formula for sine, cos, and tangent. Half angle formula for tangent can also be expressed by this formula. Now look at example 2. We want to find the exact value for sine 15, and we know that 30 divided with 2 is equal to 15. By looking at half angle identity for sine, we have sine A over 2 is equal to plus minus square root of 1 minus cos A over 2. So we can substitute in the formula. 1 minus cos A equal to, we have our A equal to 30. So this is 15, so 30 over 2. So the formula is 1 minus cos A, where cos A is equal to 30. Divide with 2. And we get the answer equal to square root of 2 minus square root of 3 over 4. Now we look at example 3. We want to find the exact value for tangent to 2.5 degree. Half an angle identity for tangent, which is this value and also this value. So for tangent A over 2, we have 1 minus cos A, and over 1 plus cos, this is supposed to be A. And then another one is sine A over 1 plus cos A, or 1 minus cos A over sine A. So let's say we use this formula to find the tangent half angle identity. So we substitute in the formula and we get the answer for tangent to 2.5 degree equal to square root of 2 minus 1. Okay, now look at this exercise. Try to do it by yourself. Pause this video and you can look the answer after this. For exercise A, using half angle identity where we know that 15 degree is equivalent to 30 degree divided with 2. So use the half angle formula. So we get for cos 15 degree is equal to cos 30 divided with 2. Substitute in the formula of half angle. So we get 1 plus cos 30 divided with 2. So remember the triangle to get 30. You must remember the equilateral triangle for 30 degree. This one should be 1, 2, and square root of 3. So we get 1 plus square root of 3 over 2 over 2. So simplify. So we get 2 plus square root of 3 over 4. This is degree, not square. Okay, now look at question B. Question B, using the half angle identity, we know that 112.5 is equivalent to 225 over 2. So we substitute in the formula. So sine 112.5 is actually equal to sine 225 over 2. As we substitute in the formula, 1 minus cos 225 divided with 2. As we look at this cos 225, so if we draw the angle for 225, we know that initial to terminal will stop here. So we know that this is the reference angle. So 225 minus 180, we get 45. So cos 225 is equivalent to cos 45. But remember, this is quadrant 3. So when it's cos in quadrant 3 will be negative. So you must remember C A S T, where C for cos positive, A refer to all of the trigonometry positive. Here at quadrant 2 sine will be positive, and here tangent will be positive. Since our quadrant lies at quadrant 3 for cos, therefore we get negative cos 45. So we substitute back here. So 1 plus cos 45 divided with 2. So now we must remember isosceles triangle for 45. So we have 45 here. Here should be 1, 1, and square root of 2. So substitute the value. So we get 1 plus square root of 2 over 2 divided with 2. So as we simplify the answer, we get 2 plus square root of 2 divided with 4. Don't forget to write degree. Sorry, I forget. This is all in degree. Now look at exercise C. So again, using half angle identity, where we know that we have pi over 12. So we change this into degree and we get this equal to 75 degree. And for 75 degree, this is also equivalent to 150 degree divided with 2. So we use the formula for half angle for tangent. So tangent 5 pi over 12 is also equal to tangent 150 degree over 2, where we can substitute in the formula. We will get sine 150 degree divided with 1 plus cos 150 degree. Again, we can find this value of sine and cos. First, we draw the axis. Initial to terminal line, and we get here. So the reference angle should be at this side. So we have here 150. So to get the reference angle, we just 180 minus 150, we get 30 degree. So we can know that for sine 150 is equal to sine 30. And remember, CAST. Now it lies at quadrant 2. Quadrant 2, we know that sine is positive, so sine 150 equal to sine 30. But we also have cos 150 here, so we want to find cos 150 is also equal to cos 30. But whether it's positive or negative, look at the quadrant. So it lies at quadrant 2 for sine positive, therefore cos is negative. So we know that cos 150 is equal to negative cos 30. Now we continue with this. So we have sine 30 degree divided with 1 minus, because we have negative cos 30 here, minus cos 30 degree, and we find the value. Since we know the formula for equilateral triangle, where for 30 degree, here should be 1, square root of 3, and 2. So as we substitute the value, we will get this answer. For D, tangent 15 degree. So by using half angle identity, we know that 15 degree is equivalent to 30 degree divided with 2. So this is also equal to tangent 30 degree divided with 2. So substitute in the formula. Sine 30 degree divided with 1 plus cos 30 degree. So we know that 30 degree so here is 1, 2, square root of 3. So substitute sine 30 over 2 divided with 1 plus square root of 3 over 2. So we get the answer is 1 over 2 plus square root of